lately, have you been looking at the headlines about, record-smashing temperatures, those out-of-nowhere torrential rains, and the seemingly endless wildfires?
Yeah.
And maybe wondering if it's just a run of really bad luck
Uh-huh.
or something more fundamental changing in our climate.
Yeah, that's precisely what we're digging into today. We're taking a close look at whether these extreme weather events are maybe becoming the new normal we need to brace ourselves for.
Okay, so to figure this out, we've gone through quite a bit of information, the latest scientific studies, detailed reports on recent climate disasters, and even some of the most reliable projections for the future.
Right.
Our goal here is to really get a grip on the hard evidence, understand how these events connect to climate change, and maybe paint a clearer picture of what the future of extreme weather might look like for all of us.
Sounds good.
Okay, so let's unpack the observable evidence first. What are we actually seeing happening around the world right now?
Well, what we're observing on the ground is it's quite alarming, actually. Take these early and incredibly intense heat waves, for example. The April 2025 heat in India and Pakistan was really significant. Delhi saw the mercury climb past 40 degrees Celsius.
40 degrees?
Yeah, and in Shahid Benazirabad, it hit a scorching 50 degrees.
50. In April.
Exactly. And what's particularly striking is that these temperatures were as much as 8.5 degrees Celsius above the typical averages for that time of year.
8.5 degrees hotter than normal.
Yeah. Imagine the early summer heat you're used to, now arriving weeks earlier and feeling almost 9 degrees hotter. That's the scale of deviation we're seeing.
That's a massive jump. And the reports are suggesting this kind of early severe heat could become, well, the new normal. What does that practically mean for people living there?
It suggests a fundamental shift in what's, considered typical. So instead of these extreme heat events being rare, kind of unusual,
Right.
they could become much more frequent and arrive earlier in the year. And that poses significant risks to public health, agriculture, you name it. Then we have this other phenomenon, something called climate whiplash. These really abrupt swings in temperature.
Climate whiplash, huh? That sounds pretty dramatic. What exactly is that?
It is quite a jolt to the system, yeah. A study published in Nature Communications looked at temperature data going way back from 1961 to 2023
Okay.
and found that over 60% of the planet experienced these rapid shifts from hot to cold or, the other way around.
60% of the planet.
Yeah. And this isn't just about needing to suddenly switch from shorts to a winter coat. It has serious consequences.
Like what? What are the biggest concerns with these sudden temperature swings?
Well, the study links these quick changes to disruptions in the high-altitude jet stream and also changes in soil moisture.
Oh, okay.
And the increased frequency of these events poses significant threats to human health, maybe exacerbating respiratory and cardiovascular issues. And it can also severely damage infrastructure.
How so?
Well, think of a road built for moderate temperatures, suddenly having to deal with extreme heat, then maybe sudden freezing. It's going to expand and contract and weaken much faster.
Right, I see.
This is a particular concern in places like Western Europe and Southeast Asia, according to this study.
So our infrastructure, even our bodies, maybe aren't really designed to handle these kinds of rapid extreme shifts. And we've also seen some really devastating wildfires making the news recently, haven't we?
Tragically, yes. The March 2025 wildfires in South Korea were described as the worst the country had seen in 25 years.
Wow.
We're talking about an enormous area, 104,000 hectares burned. And sadly, 32 lives were lost.
It's awful.
And this wasn't just, an unfortunate accident. The scientific evidence strongly indicates the role of climate change.
Okay, how do scientists determine that link? How can we be sure climate change played a significant part in those specific fires?
All right, that's where attribution science comes in. You can sort of think of it like detectives using forensic science to determine the fingerprints of climate change on a specific weather event.
Fingerprints. I like that analogy.
Yeah. So in the case of the South Korean wildfires, it's estimated that climate change actually doubled the likelihood of this event occurring.
Doubled it.
Doubled it. And it increased the intensity of the fires by about 15%. This was driven by temperatures a full 10 degrees Celsius above what was expected for that time of year.
10 degrees, again.
Yeah, combined with unusually strong winds, a really dangerous combination.
Okay, so we're seeing these really concerning extreme events happening. And there's this growing body of evidence pointing towards a connection with climate change. But how strong is that connection sort of on a broader scale?
Well, The Intergovernmental Panel on Climate Change, the IPCC.
Right, we hear about them a lot.
Yeah, they provide the most comprehensive, widely agreed upon scientific assessments on this. Think of their reports as like the gold standard for understanding climate science.
Got it.
According to their findings, with just 1 degree Celsius of global warming, which is roughly where we are now, heat waves that historically occurred maybe once every 10 years are now happening about 2.8 times more frequently.
Almost 3 times as often.
Exactly. And if we reach 2 degrees Celsius of warming, that frequency more than doubles again to 5.6 times, and those heat waves become a significant 2.6 degrees Celsius hotter.
Wow. So a once-in-a-decade event becomes almost an annual thing, potentially, and much hotter.
That's the trajectory, yeah. Within just a couple of degrees of warming, it really shows the leverage effect.
Those numbers are really striking. It's not just a small bump, it's a dramatic increase in both frequency and intensity. What about other types of extreme weather, like really heavy rainfall events?
The trend is pretty similar there, too. Extreme rainfall events, again, the kind you used to expect maybe once a decade, are now occurring approximately 1.5 times more frequently.
Okay.
And they're about 10.5% more intense with 1.5 degrees Celsius of warming. Projections indicate that if we reach 2 degrees Celsius of warming,
Which is a critical threshold.
absolutely, then these events will likely become 1.7 times more frequent and a staggering 14% more intense. More water, falling faster.
And it's not just these single types of extreme weather happening in isolation, is it?
It's it.
I feel like we're increasingly seeing them occur at the same time, or maybe in rapid succession.
Precisely. That's a really important point. We're observing a rise in what scientists call compound events.
Compound events.
Yeah, combinations of extreme weather. And this has been happening more since the 1950s. So think about experiencing a severe drought at the same time as a major heat wave.
Oh, right. That would be awful.
Exactly. It puts even more stress on water resources, ecosystems, everything. Or consider the rapid switch we talked about earlier, that climate whiplash between intense floods and then prolonged droughts.
Yeah.
The evidence strongly suggests that human activity's influence on the climate system is a key factor driving these increasingly frequent and, frankly, complex combinations of extreme weather.
So, okay, based on what we're seeing now and the scientific understanding of how climate change is connected, what do the future projections tell us? Are we on a path for even more of these kinds of extreme events?
Unfortunately, yes. The climate models consistently project a continued and even potentially accelerating upward trend in the frequency and intensity of extreme weather events. That is, if we don't see significant and rapid reductions in greenhouse gas emissions. That's the crucial caveat.
That's a sobering thought. It's not just that things will stay as bad as they are now. The expectation is that they will continue to get worse without action.
Exactly. And it's really important for people to understand that each additional tenth of a degree of global warming further intensifies these extreme phenomena.
So it's not like there's a safe plateau.
Yeah.
Every little bit matters.
Precisely. The relationship isn't linear. The impacts tend to become more pronounced with even relatively small increments of additional warming.
Are there particular regions of the world that are projected to be more severely impacted by these increasing extremes? Does it vary?
Yes, it does vary. The impacts won't be felt equally everywhere. Tropical and subtropical regions, for instance, are projected to experience a significant surge in intense cyclones and torrential rainfall.
Right, more intense storms.
Yeah, putting coastal communities and low-lying areas at much greater risk. Then, in higher latitudes, where the overall warming tends to be more pronounced.
Like the Arctic.
Exactly, places like that. We're likely to see a considerable increase in the frequency and severity of wildfires and also more prolonged periods of drought.
So it sounds like almost every part of the world will be affected in some way, just maybe with different types of extreme weather becoming more common and more intense depending on where you are.
It's a good summary, yes.
You mentioned the urgency of reducing emissions in the context of these projections. Why is that so critical right now?
Well, these future projections really underscore that without substantial and swift action to cut greenhouse gas emissions, what we're currently experiencing as, let's say, a heightened level of extreme weather could very well become the permanent baseline condition, the actual new normal.
So this isn't just a bad phase. It could become permanent.
That's the risk. The window of opportunity to prevent the most catastrophic consequences is definitely narrowing.
This paints a concerning picture of the future. If this new normal of more frequent and intense extreme weather does solidify, what kind of real-world impacts are we talking about? What does that look like?
The socioeconomic and environmental repercussions are going to be widespread and pretty significant. If you think about public health, we can anticipate a rise in deaths from heat stroke, an increase in respiratory illnesses, perhaps worsened by poor air quality from more frequent and intense wildfires, and just growing challenges related to access to clean water, especially for vulnerable populations.
Right. And beyond the direct impacts on human health, what about other areas?
Well, agriculture and our food security will face major challenges. More frequent and intense droughts and floods mean widespread crop failures are more likely. That disrupts food supplies and will likely lead to increases in food prices.
Which affects everyone.
Absolutely. And our critical infrastructure is also increasingly at risk. We could see more frequent damage to power grids as they struggle to meet surging demand for air conditioning during heat waves.
Right, like blackouts.
Yeah, or transportation networks could face more frequent shutdowns because of flooded roads or, buckled railway lines from the heat.
It sounds like it will touch almost every aspect of our lives and economies. What about the natural world, the plants and animals?
The impacts on biodiversity and ecosystems are equally worrying, frankly. Many species will struggle to adapt quickly enough to such rapid and dramatic changes in their habitats.
They can't move or evolve fast enough.
Exactly. So that leads to migrations, maybe significant declines in populations, and tragically, potential extinctions for some. This loss of biodiversity weakens the resilience of our ecosystems and poses a serious threat to overall ecological stability.
So if this is the reality we're facing, or potentially facing, what can we actually do about it? Are there ways to adapt to this new normal of more extreme weather?
Adaptation is absolutely crucial. We have to do it alongside cutting emissions.
Okay, so what does adaptation look like?
It involved making strategic investments in strengthening our infrastructure so it can better withstand these extremes. Things like improving urban drainage systems to handle more intense rainfall.
Storm drains, yeah.
And enhancing the thermal insulation of buildings to help people cope with extreme heat. Also, implementing better forest management practices to try and reduce the risk and intensity of wildfires.
Okay.
Developing more sophisticated and widespread early warning systems for extreme weather events is key so people have time to prepare.
Forewarning helps?
Definitely.
Really?
And creating public health plans specifically designed to protect vulnerable communities during these events. All these things are essential steps we need to be taking and scaling up.
So, to kind of bring everything we've discussed together here, what's the main takeaway for you? Are these recent extreme weather events just random occurrences, just bad luck?
Well, the evidence we've looked at is really quite compelling. These extreme weather events are not just isolated incidents or bad luck. They represent a clear and intensifying pattern.
A pattern.
Yes. And human-caused climate change is undeniably a major driving force behind this fundamental shift in our weather patterns. It's the physics of a warmer atmosphere and ocean.
And the severity of what comes next, it really depends on the choices we make now, doesn't it? Mitigation and adaptation.
Precisely. Without immediate and significant efforts to both reduce our greenhouse gas emissions, that's mitigation, and proactively adapt to the changes that are already underway, this new normal of extreme weather will not only persist, but will actually worsen.
And that disproportionately impacts certain people.
Yes, it disproportionately impacts the most vulnerable populations around the globe and places immense strain on our planet's delicate ecosystems. The effects are not evenly distributed.
So, considering all the evidence we've explored today, thinking about this pattern, the projections, the impacts, what are the most critical and fundamental shifts we need to see, both, in our societies as a whole and maybe in our individual actions, to truly confront and address this evolving climate reality? It's definitely something profound for all of us to consider, isn't it?